Hey everybody, this is Larry. This is day 26 of the January Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem in Today's problem is 1305 all elements in two binary search trees. Given two binary search trees, return a list of all containing all the integers from both trees sorted in ascending order. And they are binary search trees, so okay. I guess the idea here, which is kind of maybe annoying to implement, is kind of do traversal one at a time, but then almost like kind of getting a linked list one at a time, so then you can kind of compare them in linear time, and taking the min of each one, um, or getting the min assuming that they're equal. Are they unique? I guess they doesn't say whether they're unique. I mean, obviously they're not unique across two trees, but um, hmm. But yeah, so that's what I would do. But and there are a couple of traversals you can do. Technically, there's like the Morris traversal or something like that, but that's also a little bit dubious, to be frank, in that it does like modify the input, right? So it's hard to say that that's constant space, though technically I guess you can. And I guess I'm trying to think about how to do it without um, without Python wizardry. What I mean by that is having like some sort of yield type thing. And actually, I actually don't know that well. I mean, I know it enough to solve it for this problem, though I don't think I know it that well to kind of I don't think I know it that well to like do it without the Python sugar. So yeah, but okay. But I would say these things are room for experiment, room to try. So let's play around with that though. Yeah. Um, like playing around with using an enumerator and got some stuff on my keyboard. Um, and yeah, so then maybe we could get get node from tree or something like that. I actually don't know how to write this in a good way, so we'll see. Okay, so node, and this node has if is it like you get node dot left, and then you node. My period didn't show up. I sound like a high school whatever, but okay. So something like that, and obviously you have to go if node is none, return. Does that work with this? I don't know. Maybe I have to add an if statement. I'm trying to learn here as well, so hopefully this is you know uh, hopefully this is entertaining, though I know that this isn't what you want. But yeah, but you can also do it another way, to be honest, which is the the whatever way is to just do a depth first search or an in order traversal of both trees. What I meant to say, I don't think I said this earlier, that's my bad. So you do an in order traversal, put in a list, and then just walk the list, right? So you can definitely do that, but I'm trying to do it maybe a little bit fancy, or not fancy, but just funky maybe. So we'll see. Is this right now? Because it looks like I did the two and then one and then I don't know. I don't know. I think that. Oh wait, no. I don't know how this works with this printing. Maybe I could just print here then, and that would be. Oops. Oh, but I think that doesn't do everything, right? That's just. Don't know what that does. Okay. Maybe I'll do something like what I wanted to do is something like this. So let's see if that works anyway. Oh, it's a generator. How they Isn't this a tree node? Am I thinking of I really have no idea how to do this, do I? So okay, so we're all learning together. I know how to do yield stuff, but maybe not necessarily in a recursive way. So this is new to me. So we'll learn a little bit together. So this is a generator. How did I collapse the generator? Or did I do this incorrectly altogether? So there's a generator on 2, on 4. I don't know what that means. Oh no, it's just on the top node. How did I collapse this? I don't know why I'm asking it like that, because obviously I'm off stream or anything. But all right, let me do some quick looking. Maybe this isn't it. Maybe this is just okay. Maybe I meant to do this. It's a little bit better, right? I think I was just mixing things up and confusing myself. Okay, I think this is right. Okay, I think I just confused myself a little bit in because what I was thinking about, for some reason, a little bit mixing it up in my head. Though maybe. This is still not good, obviously. It just has the root node. Let's see. Oh, yield from. Okay, so I think I was using another thing, but maybe this is it. Hopefully, maybe. Let's see. I thought I was. Yeah. Okay. There you go. Okay. So I think I confused some syntax a little bit, because to be honest, one of the in my previous life, if you will, some things that I did with this was doing what's it called? What's that Facebook thing? Tornado? Friends feed thing. I use Tornado, and I'm using yield to kind of do async stuff. So I think I have some something mixed up over there. But as you can see, yeah, you can use this to kind of do the recursion, and of course you can also do this for root 2 as well. So yeah, so I'm learning with you as on how to do recursive generators. So that's kind of fun. Okay, so still 1 through 8. So yeah, now that we have 2 generators, we can do something like let's see, how does. Okay, so then maybe we do something like gen 1 is equal to get node of node.left. Something like this. Oh, sorry, this is root 2 and root 1, obviously, but okay. And then this should be gen 1, gen 2, right? Okay, so this is a generator, and then now I think it's next. Is it next or item? I forget how the generator item. How do you collapse the generator? I don't. Sorry, friends. This one is a little bit messier than I would like. Because I know this the next gets you the next one, but how do I get like the first item? So I want to do it like one at a time, so I only go to the next if I have to, right? Is it just like iter? I mean, that returns an iterator, right? Like, how do I go the other direction? To item. iter items. Is that it? Iter first item. Is it? I'm just like Googling a lot because all these like examples of it puts it in a for loop, and I don't want it in a for loop. But I want to manually do the for loop. Like, how did I just get the? Oh, then maybe I just have to do like the next. Maybe the first item is a generator. Is that right? Maybe I got confused here then. Okay. So I was wrong on something. So this is basically the beginning of the generator or whatever. I don't know the terminology in Python. It's been a while. But yeah, but we can do something like, okay, next. Is there has next in Python? Has next, or is it just none? Okay, fine. So, okay. So, while Gen 1 is not none, then, and Gen 2 is not none, if, okay. But first we have to do, I guess we have to go through the next item, or the first item in this case. This is very awkward and definitely not the way that I would normally implement it, but I am trying to figure out and learn a little bit. So some of this maybe a little bit shaky, which, you know. So thanks for watching this and kind of hanging out with me. But okay, so then now, rather than not none, if Gen 1 is equal to Gen 2, we push it to an answer, right? So answer.append Gen 1. Because they're the same, so it doesn't really matter which one you append. And then else if Gen 1 is less than Gen 2, then we pop that one off, right? So Gen 1 is equal to next of Gen 1, else Gen 2 is equal to next of Gen 2. Okay, and then at the very end we could return answer, and hopefully this works. Oh, I thought I clicked on it, and then I got a minor ping. Oh, oh yeah, of course this is wrong. It's because this has to be a thing, and yeah, we're comparing the value and integers. So yeah, so we should append the value instead. Okay, of the tree node. Tree node is not an iterator. How do I? What is going on? Is it this? I really don't know I'm really clearly confused about the syntax. So okay, so I get the next of this. Okay, so maybe I'm doing it a little bit wrong, because I think I overwrite it here. Okay, fine. This is not the syntax that I would imagine it be but you know, maybe that's part of the fun and joy is learning this stuff. Okay, so then now and also I have to compare the value. That's actually a mistake that I'm glad that I actually noticed now. It's a little bit late, but still. Okay, so then now we want to update. Oops, it's equal to next of Gen 1. Yeah, like I said, this is more learning code. So yeah, at some point this got a little bit odder than it is. And I would also say, well, I would also say I hope that this runs, but yeah, in theory this will allow us to have O of 1 or something. So, oh yeah, this one this answer I forgot to do, which is that we pop off from both, right? So that's why it's yeah, okay. Yeah, so this is definitely very convoluted and definitely maybe I mean, I guess I could do so I know how to the Pythonic way to do it is actually just to try catch this, but I thought that this would be none. Like, I thought that this would return a none first, but I guess not. Okay, fine. This makes it a little bit whatever, but oops. Okay. It is unfortunately wrong though. So the smaller one, yeah, we get the smaller one, right? Man, okay. Well, let's see what I'm doing here. This code looks okay though, right? No? Okay, so 0 and 1. 1 and 0, which is true. 1 and 1, okay. And then take the next number, but then it stops. What is that? Do I have an issue somewhere? Do I have a typo anywhere? It's either that or I maybe I don't do it correctly quite here. No, we printed everything, right? So, huh. I mean, I know this is a pretty straightforward, easy problem that, to be honest, if I was doing it in a contest, I would probably do it in about a minute. But today I am trying to learn something new. But today I'm having some issues. And also, I think I messed up because on the first one, it actually doesn't do anything. Is this right? Am I doing this wrong? Like maybe I'm only doing one comparison and that's why, because maybe only this part gets compared and I don't even iterate through it because I'm doing multiple test cases. So let's double check that. So anytime we have a next it's wrong, is that the situation? How did that happen? I don't know the syntax behind this, apparently. So oh, so this should be like get gen or something, but okay, we'll worry about that a little bit. Why is that? I thought that the generator. Can you keep on, like, am I just using the generator one? Maybe that's why. I think I'm mixing iterators and generators, and I think that is maybe the issue. Like, do I have to do something like this? I'm a little bit confused. That's unfortunate. So basically what it's saying is that after one iteration, I guess we have to, get rid of the 0. So it goes to here and then it hits the stop iteration and then it bugs out. How does that happen? I just don't know the syntax. I mean, I think I just don't know the syntax is a short answer, really. But generator 1 by 1. I mean, I guess I don't know anymore. I'm so lost. Why doesn't this work? Shouldn't this just work? I just don't know the syntax, and this is bugging me, I suppose. Okay, let's just do, okay, while node 1 is not none, maybe? Node 1 is equal to gen of next of gen 1, print node 1 dot value, maybe. Just curious. I'm learning here as well, so maybe that in the future. So it does print out everything. Do I just have a typo or something like that, or what's going on? Yeah, I mean, this is what I expected, and it is right until it ran out of things, but that's fine. That's actually, I mean, I was half expecting is either this would work or the stop iteration. So yeah, so this works. So then why if I interlace it, it does not work? Dong dong dong. So 0, okay, and then it crashes out, right? But why doesn't it here? Did I have a typo in any place? Is that why? Or is there some funky thing where yeah, okay, yeah, so after that did get propagated. Oh, I'm just being dumb, am I? Because I took away the while loop. I think that's why. So, okay. I think I just confused myself a bit. I replaced the while loop with the try loop, and that actually was silly, obviously, because now it just does one iteration and that's it. Okay. Oh, also I misread the problem for some reason. Huh. For some reason, okay. I mean, clearly, if you if you notice until now, you realize that I totally misread the problem as, I mean, I read the problem, but I solve it as the one where you have to get the duplicate copies, but it just doesn't matter. It's just in ascending order. So in this case, we can, okay. I mean, it's the same idea. I would write this a little bit differently. Yeah, but now it's a little bit awkward, I think, to be honest, because now it'll stop out early. Maybe that's okay. We'll just have to add. This is definitely a little bit more awkward now, but yeah, but I could do something like this. Right, and then just like a regular thing, you would have to do the other thing where, you know, but this is also very. Now this is getting very verbose, to be frank, but maybe now actually I can do it the other way, right? So yeah, so for x in gen 1, n start append x dot while, and then for y in gen 2 or x in gen 2, maybe I could even just I could have concatenate here, but maybe I've been too adventurous for one day, so let's just do something funky like this. And then okay, so I missed one. Oh, I missed one because the one that we didn't update, let's say we generated, we don't actually add that one, and it's no longer on the iterator. That's a yucky thing. Okay, so I guess I can put it here. I'm curious, what happens, like, does it still overwrite node 2 if it runs out, or is it just none? No, so it's still there for tree node 3. It's just that next returns none and it gets stopped. So that's a little bit annoying, actually. This is what I get for trying something new, I suppose. I get all this weird edge case that I did not plan for. Also, I misread the problem, to be honest. So, but now I have to figure out how to. But basically, what happens is that this gets popped off the iterator, and I have to put this into the thing, but I cannot do it without kind of adding a yucky thing of tracking which one was last or something. Because yeah. That's a little bit annoying. Okay, fine. Okay, fine. So if the oh, should be before the possible error. This is very yucky. I do not recommend it, by the way. It's just Larry trying to learn something new, and you could debate that that's useful or not. But this is a mess. Not gonna lie. If left, that means that we want to take it from the right. So okay. Okay, this is a long way to do this, but I should know this when I saw this. But okay, let's also try 0 nodes because I feel like I missed that yesterday. Okay, let's see. Which one? 921. Oh, because that's no items. I hate you. Actually, I mean, this is fine. I could put this here. So, and in fact, it maybe should have been anyway. I guess this one I didn't have to go out inside, but it's the same nonetheless. Oh, okay, so I was wrong. Actually, this has to be outside because of that. Scoping, I forgot about this. Node, that's annoying. Okay, fine. I mean, basically what you would do is that what we want to do? I think actually, this is so awkward. Oops. Okay, how do I want to handle it? I mean, I should catch this outside, but it's just okay, fine. But then now there is even more complication. This is definitely not something I would recommend. But I'm having fun though. Are you having fun? It's always good to learn something new. Okay. What happens if this is none? Well then, I hate you. Maybe I should have done it this silly way. Okay. Yeah, okay, fine. I think I'm gonna cheat for this one. And by that I mean I'm just gonna create the fake one is equal to yeah. Okay, so then now I don't have to worry about this, and then I just take okay, fine. I mean, yeah, I'm a little bit lazy on this one. This technically takes an extra end space, but I'm gonna go with it. Oh yeah, I forgot to put this back, and also I forgot to use this instead. Oh. That's unexpected. Why would that not be the smallest right? Oh, because I messed up and I put this on the left. Though it should be on the right. Whoops. Because putting it does not automatically make it magical. Okay. Yeah. Oof. Yikes. But this is also, to be honest, this is a good habit for a lot of things, is so that you could get away with not caring about a zero node situation. But yeah. Okay. Let's give it a submit. Hopefully this is right. Like I said, this is a first experiment in something funky. Hopefully it's fast enough. If it times out after all this, I'm going to be a little bit sad. And I do know that someone told me that this is actually probably n squared time or n squared n squared time. I could be wrong about this, but someone told me something like that about recursion. That's why I don't really use yield with recursion, but yeah. So I mean, it's gonna be really slow, but at least it passes. That's fine, I suppose. We'll go. I don't really want to go over this because it's already been half an hour in. You could kind of check it out. I will check another video. We'll check my older solutions really quick. And I guess this is how I would do it. I would just make things in an array and then just go through it one by one and then merge them in linear time. So that's going to be linear time and linear space. This one, but yeah, check out that video. I probably have a video. It's definitely part of the series that I've been doing. This one, I don't know the complexity about these recursive yields. Like I said, someone put some doubts in my head. But also, obviously, the running time is terrible. So, but otherwise, ignoring the depth first search for now, then everything else is kind of O(n). So linear time, linear space, ignoring this part, do your own thing. Anyway, today, like I said, I'm doing it in a really funky way. Hope that is interesting. I don't know if this is good. Take it back. I know this is not good, but you know, sometimes learning is about exploring different ways of doing things, and you know, this is it. This is that. That's all I have with this one. If you do have questions about this particular problem, check out my older video. Maybe I have a link below. Should be okay. I mean, yeah, and yeah, let me know. Let me also, I guess, really quickly put up that submission on the screen so you can kind of see. But yeah, I don't even know that I like this code per se, but I just basically create a list, and then this is in order traversal, like I said, and then yeah, and then this is the same code that we have in the other one, which is that we get the min element to put it in the front, and then we keep going. Cool. That's pretty much all I have. Let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see you later. Bye bye.